Hello, welcome to PrepStation Chemistry SSCE tutorials. We are going to look at redox reaction, and under this topic, we're going to look at definitions of term, which is reduction and oxidation, and also look at try to differentiate between reducing agent and oxidizing agents, and dive into calculating the oxidation numbers of elements in a compound, and try to see how we can write and balance a redox half reaction equations, and also balance redox reaction equation. Then lastly, discuss the tests for reducing and oxidizing agents. Okay, firstly, what is reduction? Redox reaction involves a chemical reaction, in which the reduction and oxidation occur simultaneously. Now, not all reactions are redox, It can only be a reaction in which there is a transfer of electron, in which one substance is oxidized, and another substance is reduced. So in this process, let's look at, for example, this is a reaction between A and B. A and B give us for another A and B. In this process now, these are our reactants. A plus B is our reactant, while also A plus B also was our product. But at this point now, one of these reactants is losing electron, another is gaining an electron. All right, so I will explain. This is an example of a redox reaction. A and B are the reactants. This is reactant A and reactant B. In their normal neutral state, we have a chance of 0. All right, it's not losing, it's not gaining. But at the process of redox reaction taking place, reactant A now move to the next level and lost electron and becomes a positively charged. All right, whereas the next one, which is B, gain an electron, becomes a negative charge. So this process is what we call reduction oxidation reaction. The two processes occur simultaneously. So now, if you look at the second part of the equation, from A, from A to the next A in the product is called loss of electron, meaning that at this point, this A have lost one electron and becomes just a positive sign. Then this B on the neutral side, have gained an electron and becomes negative. So all this happens simultaneously. That's why you say that redox reaction is a chemical reaction involving simultaneously oxidation and reduction process. That also means redox means reduction plus plus oxidation. In this reaction, one of the species is is oxidized. For example, A is oxidized in this reaction, meaning that A have lost electron, whereas B is is reduced, meaning that B gain an electron. So the whole of this process is known as a redox reaction. So let's define it individually. What is reduction? Now, reduction is the opposite of Of oxidation. Take note of this. All right? So when there is addition of hydrogen, we call it reduction. And when there is when the addition of oxygen is called oxidation. So it's the opposite of each other. Now, the removal of oxygen, removal of oxygen here is termed as reduction, whereas the removal of hydrogen here is termed as oxidation process. So it's the opposite because they happen simultaneously. All right, one cannot function without the other. Now, the addition of a more electropositive element is reduction process, whereas the addition of a more electronegative element, is known as an oxidation process. Then the removal of a more electronegative element, is known as a reduction process also. And what is the opposite? The removal of a more electropositive element is known as oxidation. Then lastly, this is the most vital definition of oxidation, involving the transfer of electron. So a condition involving the gain of electron, is known as reduction process, as what we see in the previous picture. All right. Whereas a condition involving the loss of electron, when one part is gaining, another part is losing. So combining these two processes together give us reduction oxidation reaction. Okay. Now, this is a little table that will give us more understanding about the processes. Now, look at this very well. Look at the direction of the arrow. The arrow is pointed both forward and backward. Now, looking at this number, this is like a number line, all right? So from -4 to +4, something is happening when you're moving from left to right, okay? Then at the point of, from my right to left, is from +4 to -4, something is also what's happening. And then look at this. Now, from -4 to 0, okay, then from 0 to +4, when you're moving from your left to right, shows that this is loss of electron. Meaning that if a compound contains -4 and a compound contains +4 as a charge, all right, the one that have a -4 contains more electron than those of +4. So that means that if we are going from left to right, we are losing electron in that particular reaction. Now let's look at an example. For example, I'm using iron here, for example. Okay, at this process now, my iron here is has a 0 charge. This atomic number of iron as 56. Okay, so as you're going from 0 to +1, now come back to this point. All right, this is my 0 to +1. This is my process. So that means that at a neutral form of iron, we have 56 atomic number. Okay, now when it loses 1 electron, it becomes what? It becomes 55. Are we together now? So in this process, it's called what? Oxidation. But when you see where my arrow is going, looking at, my arrow pointed from right to left, means that from +3 of iron to 0, that means that from this point A, call this point A, to point B, iron is what? Is gaining electron. You can see now, 53 to 56. So from point A to point B is called what? Reduction process. But if I revert this arrow, it becomes what? It becomes an oxidation process. It means that losing an electron. It lost 1 electron, it becomes 55. Lost another, becomes 54. Lost another, becomes what? 53. Now let's go back to the reduction process. As I said before, look at the direction of my arrow from my right to left, using the same number line. So a compound that contains +4 and 0. Now this 0 contains more electron than those in +4. Now let's use sodium for example. Sorry, the iron for example. This is my +3. Okay, +3 and 0. Atomic number of iron here is what? A 53 at +3. That means that this guy lost 3 electrons. 3 electrons from here and become 53. So as it's moving towards the what? Towards the left, it's gaining back electron and becomes +0. And this is the normal what? Atomic number what? Of iron. Now let's come to the chlorine. Chlorine is a non-metal. That's why you have what? The negative sign. It's okay. So at this point, the charge of chlorine here is what? Is 0. All right? 17 atomic number, then 0 charge. This is the normal neutral chlorine atom. Is that okay? But as it's moving from this point, from 0 to -1, okay, what happened? It has gained 1 electron to itself. That's what we have from 17 here down to 18. So as it's moving again to have -2, but this does not exist. I'm just giving an example. There's nothing like -2 for chlorine. It's just an illustration. Is that okay? So moving from 18, okay, to 19 means that he has gained what? 2 extra electrons to itself. So 17 plus 2 give us what? 19, which is what? Gain of electron. So this is a number line that illustrates oxidation process and also what? Reduction process. So moving from minus to plus, okay, is called what? Oxidation process, meaning what? Loss of electron. Okay, or you can say at this point now, this process, substance that does this, okay, are being what? Oxidized. They have lost an electron. But substance that undergoes this process from plus to minus are being reduced, meaning that they have what? They have gained more electron to what? To their atoms. All right, let's proceed. Having known that, let's look at what is oxidizing agents and reducing agent. These are the agents that causes both reduction and what? And oxidation process. Now, what are they? As usual, they are the opposite of each other. For example, electron acceptors, okay, in any particular redox reaction are known as what? Oxidizing what? Agents. Okay, so they accept electron. They gain electron to themselves. Whereas substances that do what? That donate electron, that gives out or lost electron, are known as what? Reducing what? Agents. Okay, now substance which is reduced, this means what? Which gain, which attract more electron to itself, okay, are known as what? Oxidizing agents. Whereas substance that does what? That lost an electron, okay, are called what? Are being oxidized, and they are called what? Reducing agents. Now, substance in which oxidation number decreases in the positive direction is called what? Oxidizing agents. And also, a substance in which what? Oxidation number increases in the positive direction is called what? Reduction what? Reducing what? Agent. Then what are the examples? These are, for example, this is potassium tetraoxomanganese 7. Okay, this is potassium heptaoxomanganese 7. Okay, example of oxidizing agents. Then this is also potassium hepta. Okay, because it's 7 here. Potassium heptaoxodichromate. Di because we have 2 here. 2. Potassium heptaoxodichromate 6. All right. Then this is manganese 4 oxide, hydrogen peroxide. All iron 3 salts are oxidizing agents. Okay. Then chlorine, oxygen. This is most non-metals. Okay, are oxidizing agents like the halogens, the fluorine, the chlorine, the iodine, bromine. They are all in the area in the oxidizing agents. Then most metals, okay, metals of group 1, group 2, group 3, okay, transition metals, because these ones are what? Are givers. They just like, yes, give out their electrons and become stable. All right. For example, if you have something of this nature, all right, let's say you have something like sodium, for example. Sodium, okay, has electron atomic number of 11. At this point, sodium is not stable. Okay, we have one S2, 2S2, then we have what? Yes, one S2, we have one S2, 2S2, 2P, 2P6, and what? 3S1. Is that okay? Now, this is where sodium gains its stability. 2 plus 2, 4, 4 plus 2, what? 6. Now, this last electron makes sodium what? Uncomfortable. So this is why the sodium will now do what? Let go of the last valence electron and becomes stable. So when this happens, you're going to have sodium from 11, okay, from 11 to sodium of plus, meaning that one electron is missing from this point and becomes what? 10. At this point now, sodium have gained stability like a noble gas. Okay, so at this point now, if you want to go by this, they will give us what? Electron configuration of 1s2, 2s2, and 2 what? 2p6. This is more stable than this compound. So at this point, sodium do what? Give out the electrons, okay, and becomes a stable element with a charge of what? Of +1. So almost all the metals behave like this. That do what? Donate electron, give out electron, and gains their what? Their stability. And other examples of these reducing agents like hydrogen, carbon 2 oxide, hydrogen sulfide, sulfur 4 oxide, potassium iodide, ammonia. Then all iron 2 salts, okay, are what? Reducing agents, sodium and other what? Other metals. So most metals are what? Are reducing agents, whereas most non-metals are what? Are oxidizing agents. Because they do what? They accept electron, while the metal do what? Gives out electron. Okay, let's continue. All right. So this is a picture that further demonstrates what I just explained now. Reducing agents and what? Oxidizing agents. Now look at this diagram very well. Now, for example, X and Y. All right. Now X do what? X gives out electron to Y. Okay, look at it very well. Initially, X was okay with the 0 sign here, and it gives out electron to Y, and Y do what? Receive, okay, and get more electron from where? From the X. At this point now, X is a reducing agent because it gives out electron to what? To Y. Is that okay? And Y receives it and becomes what? An oxidizing agent. As I said, that X loses electron, Y gains electron. Okay, at that process, Y is being oxidized, means that, sorry, X is oxidized, means that X has lost something, has lost one electron, okay, to what? To what? To Y. Then Y now receives the electron from X and becomes what? Becomes more, okay, in size compared to what? Compared to X. So that's what happens in redox reaction. It's a simultaneous reaction where this process happens at the same time. Now, the short form for this reaction is known as OIRIC. OIRIC means that O stands for oxidation, I stand for S, then L stands for what? Loss. So if you don't remember anything, don't forget this, that OIRIC can give us what? A simple definition of what? Of redox reaction. Oxidation is a loss of electron, whereas what? Reduction is what? Is a gain of electron. During the process, Y is oxidized by what? By X. Sorry, X is oxidized by Y. Okay, that means that Y gains electron from where? From X. And becomes what? Reduced. Becomes increased, okay, in size. Whereas, in this point now, X increases in oxidation what? Number. All right, from 0, here it will be from 0 to plus 1. X will now be like from 0 to where? To plus 1. Okay, so the number now increases in the positive direction. Is that okay? Whereas the Y now decreases from where? From 0 down to what? To minus 1. Meaning that it has gained electron from where? From the X. As this electron is going out, it goes to where? It enters what? Y. That's how it works. So it's a simultaneous process. Okay, let's proceed. Now, let's look at some examples of this redox reaction. I said before, not all reactions are redox. Not all reactions are redox. A reaction must be redox when there is a transfer of electron, gain or loss of electron, when there is a removal or addition of hydrogen, or a removal or addition of oxygen, and so on and so forth. Now, let's look for it. The first example is addition of oxygen. Now, let's look at the first reaction. The first reaction. This is carbon reacting with what? With zinc 2 oxide, though it's well balanced. Okay? C plus 2ZNO. This is zinc 2 oxide. Now, the products give us what? CO, copper 2 oxide, and what? And zinc. Take notes. Addition of what? Of oxygen. Now, look at this together. Carbon in the reactant side is without oxygen. All right? But what happened at the products? There is an attachment of oxygen to it. So at this point, which of this part of reaction is oxidation process? That's why we have this, okay? From carbon to carbon 2 oxide is what? Is oxidation process, because what? Oxygen is added to carbon from this point to this point. Is that okay? Then what of reduction process? It means what? Removal of what? Of oxygen. That's why we have at this point now zinc 2 oxide, okay, becomes what? Normal zinc. What happened here? At this point, oxygen is removed from the zinc 2 oxide and give us a normal metal. Okay, now let's look at the agents now. What causes reduction? This is very simple, all right? No need to cram this. What if you identify the two processes, reduction and what? Oxidation, to get the agent is not hard, because what gives rise to reduction is what? Oxidizing agents. All right? Now the substance that causes what? Reduction is called what? Oxidizing agent. While the substance that causes what? Oxidation is called what? The reducing agent. Just identify the oxidation process, okay, and reduction process, you can get what? Their agents. Now look at this equation again. From carbon to carbon 2 is what we call what? Oxidation reaction. So at this point, your carbon now is your what? Is your reducing agent. Okay, look at this now. And what are they? They are electron what? Donors. They release whatever they have. Okay, then oxidizing agent is what? Now, all right, look at it from this point to this point, all right? So this and this is called what? Reduction. Loss of what? Oxygen. So the agent is what? Is oxidizing what? Agent. So just identify the two processes, then their agent is gotten from where? From the process identified. All right, another example is addition of electronegative elements. Electronegative, please, is not M, is N. Electronegative elements. All right, now let's explain this more. All right, now this is the main reactant, hydrogen sulfide with bromine. All right, now between hydrogen sulfide and bromine, bromine is more electronegative, take note, than sulfur. These two elements are non-metallic, okay, and they are electronegative in nature. They carry negative signs. But between the two, which of them is more electronegative? It is bromine. That is why the bromine is able to do what? Displace sulfur in the product. Okay, this is my reactant H2S plus Br2. So one of these Br, this is like this and this are the same thing. One of these Br displaces sulfur from this compound and becomes what? HBr. All right, so now we are adding more electronegative compound to what? To the hydrogen at this point. Okay, now this guy now becomes alone because he has been displaced. That's why we have sulfur standing alone, okay, in a solid form. So at this point now, this is a redox reaction, okay, because we are adding more electronegative elements to what? To the hydrogen and become this and displaces the sulfur and it stands alone. At this point, from this point to this point is called what? Oxidation process, don't forget. All right? Then from bromine, this bromine to HBr is called what? Reduction process. Addition of a more electronegative element, then removal of a less electronegative element. So what are their agents? What causes the oxidation is called what? Reducing agents. Note, it's always taken from the reactant, not from the product. All right, take notes. The agents are not from the products. They are gotten from the reactants. All right, let's look for more example so you can get more understanding on this.